This is the phospholipid bilayer. It allows certain molecules to pass through it in a variety of different ways. This model will demonstrate a sodium-potassium protein pump. The structure in the middle of the phospholipid bilayer is a carrier protein. There are 6 sodium ions and 2 potassium ions outside of the cell, and there are 3 sodium ions and 6 potassium ions inside the cell. Protein pumps are a form of active transport and need energy to function. This is ATP, the energy that will move the sodium and potassium ions against the concentration gradient. ATP stands for adenosine triphosphate. It is constructed with a nucleotide and a chain of phosphates. 3 sodium ions are entering the carrier protein. They attach to the inner walls of the carrier protein. The ATP molecule attaches to the carrier protein. The ATP breaks away from the carrier protein, but it leaves a phosphate attached. This causes a chemical change that changes the shape of the carrier protein, which gives the sodium ions access to the outside of the cell. The sodium ions move out of the carrier protein and exit the cell. 2 potassium ions move in, attaching to the inner walls of the carrier protein. The phosphate breaks away from the carrier protein, and the protein changes shape again with its absence, letting the potassium ions access the inside of the cell. The potassium ions exit the cell, and now both sodium ions and the potassium ions have crossed the cell membrane against the concentration gradient.